you doing, guys? Bioinformatics guy here with another video of the series Python for Bioinformatics. This is gonna be the video about a bit advanced topics in the for loops, and we will be talking about different approaches in the for loops, and we will be covering combine, count, collection combine, search, filter do, filtered combine, filtered count, and the very last one, but not the least one, nested iterations. So let's start coding. So this is gonna be our 18th video, so I will put a heading here, and this will be for loops part 2 of 2. And this is a bit of advanced topic for loops. Understanding all the possible ways to use the for loops is very helpful for Python programming skills. So as I discussed earlier, we will be talking about few different approaches, and before we start I have to define a function, and that function is gonna be reading the FASTA file, and then it will return us the details in the description line which starts with the greater than sign, and then it will return us the sequence. So it will return us a tuple, and the first element of the tuple will be a list containing some details about the sequence, and the second element will be the sequence itself. So we will be using the for loops. This is gonna be a bit of complicated for you at this moment, but you don't need to worry about it. Once we go through the video, things will get really easy for you. So we will start with the def keyword, and we can name this read. We can say read FASTA, and we will of course be giving this a file name. Okay, and then we will have to open the file, so we will say with open, and then we will be like file name, and then we will be renaming it as file, and here we will do our return statement. But this for loop is gonna be in the form of the list comprehensions. So we will write our return statement, and then here our list comprehension starts. So we need basically two parts, and our first part is gonna be the 0th item, and we will split it by that bar sign. Before I continue, I guess it would be better if we take a look at the FASTA file. So I have a bit of different FASTA file this time, and as you can see that there are these bars in the description, and we will be splitting our first line of description by these bars. Okay, so that's why we will be using the function split, and we have used this function so many times earlier, and we will put the bar over here, part 2 dot replace, and we will replace the next line character, which is gonna be at the end, with the empty string, nothing, not even the space, and then we can simply say for part in, and now we have to do some magic over here, and we have to do another list comprehension, and we will this time our iterative variable, we will call it entry, and now we will use this partition function, and this partification basically divides your stuff on the basis of a special character, and we will special character or a string, so we will use this /n thing which is the next line character, and then we will complete our list comprehension for entry in file dot read, and we will read the line, and then we will use our split function again, and we will be splitting it by this greater than sign. You see in our file, faster file over here, we have every new sequence starts with this greater than sign. If you can see over here in this right corner, this huge white thingy is one sequence, and then this line over here is the another sequence starting. So see, this is another sequence starting over here, and the other sequence ends over here. So yeah, so we are splitting it by this greater than sign, and then we want to ignore the greater than sign, so we will start from 1 and go till the end, and then I can take this bracket on the top, and that's pretty much it what we have to do in our function. So let's call this function and see what we get. Okay, oh no, yeah, okay, so read faster, and then I have to give it the name of the file, which is gonna be sequence.faster. Okay, so did you forget parentheses around the comprehension index? I guess yes. The problem is this bracket over here, and yes, because we are going to return a tuple, and the tuple is supposed to be in the parentheses. So this is going to be the first part, and this is going to be the second part of our tuple. And let's run this again. So this is simply a warning actually for this showing the stuff, like it has some sort of limitations, but you see we got this first element of the tuple, which is a list, and it has some details. So it has first GI, and then it has the ID, then it has this thing, then it has the full description, and now here our sequence starts, and the sequence is not inside the list. We just have some list of some details, and then we have the sequence. Sounds good to me, and it's time to move on. And there is so much sequences over here, so what we can do is rather than just printing all thing, we can just print maybe 2 elements. So we will be like, give us we can go from start till 2. Okay, so we see we have this GI and blah 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 blah, and then we have the sequence, then we have the details of the second one, and we have this. Oh, so last time we were not using the print statement, and this Jupyter Notebook was printing itself, just the return thingy, and now we have used the print statement, and it's printed in a bit different way. And it's time to start our first topic in the advanced for loop, which is combine. So in our last video we were talking about the collection, like we started with an empty collection and then ended up with like a collection of the stuff we iterated over in the for loop. But this time we will be combining the results, and there is like a very minor difference between the previous collection thingy and this combine. I will add the descriptive details in my website as well as on the GitHub page, but right now we will directly start with the pseudocode. And so we will start with a result which is going to be an identity value. And remember, the identity value for multiplication is usually 1, and for addition the identity value is usually 0. And if you know the basic concept about identity value is that even if you add or multiply this value, the results should be same. Like if you add 0 to anything, results stays the same, and if you multiply 1 by anything, the result stays the same. So our initial result is supposed to be an identity value, so we will say result is equals to identity value, and then we will start our for loop for item in collection, and then and then in the for loop we can do 3 different things, and one of these things will be used in the combine approach of using the for loop this way. So we can update the result, and this dot I'm gonna show you right now. This dot represents any operator, like it could be addition, subtraction, multiplication, division, anything. I'm talking about this highlighted dot over here. Okay, so then we will multiply or add or subtract by item. Okay, and I will add a small comment that one of these will be used. Okay, and then we can do it in a bit slightly different way. You know this already. Dot is equals to item. So this is like a shorthand notation to do the same thing as above. Okay, and then there is another thing. So we can apply a whole function on the item and our previous results and get something new, and then add it to our result or update our result. So we can say result is equals to function call here, and we will give these 2 parameters, results comma item. Okay, and at the end of the day we are gonna return the results. So because after all the iterations of the for loop over here, our result will be in the final condition, so we will return it. And let's try to use this approach in a bioinformatics function. So this time we will try to find the longest sequence in a given file. So we will say def, and then we will name it longest sequence. I guess I can use camel notation, longest sequence, and then we will give it file name. Okay, so we will start with our identity value, and identity value for strings, it could be like an empty string. So we will say longest seek is equals to empty string. Oh no, I don't need this. And then we will start our for loop, and now we need to use the function that we defined previously, read faster, and this read faster returns basically 2 things, info and the sequence. So we will be using 2 iterative variables, info comma seek in read faster, and we will give it the file name. Okay, and then we have to update our longest sequence. So we will update our longest seek, as we are supposed to find the longest sequence, so we will use the max function over here. Max function is gonna return us the longest, the maximum value. So we will give it the longest sequence, and then we will give it the seek. Okay, so we will give it the previous longest sequence, which is basically gonna be an empty string at the beginning, and then we will also give it the seek. and then we will use the key len. So by using this key len parameter, this is gonna find the length of this seek and then find the length of this longest seek, and then if whoever's length is bigger, it will keep that sequence and we will end up with that one. So this is a pretty sweet function which will do like a lot of tasks for us, and then we will return longest, okay, longest sequence. Okay, sounds really good. So yes, let's take a look. All of the sequence seems very similar. What we can do is we can do one thing. Let me duplicate this file, and then I can rename this longest seek. Okay, I'm renaming this as longest seek because I am gonna edit this file. So what we can do is we can leave our first sequence just like that, and then we can delete some or maybe a lot of lines from the sequence. So this is a small sequence now, and then we will delete a lot of lines from here as well, and then we will delete a lot of lines from here as well. Okay, more lines from here. Okay, then delete a lot of lines from here, and in the very last sequence we can delete this. Okay, now you see this, this our first sequence is the longest one and the other sequence are smaller ones. So we will save this, and then we will run our function with which file, we will run it with longest seek dot fasta, and we got our sequence, and you can see that we really got the longest sequence. So, and it starts with TTA TTCC. So we can check it starts with TTA TTCC, and if we check the second sequence, it starts with G, it starts with C, starts with G, it starts with C. So it is returning us the correct sequence, the first one, which we know is the longest sequence. All right, so we have used the combined thingy. Next we have to use the count approach, and the count approach is basically very simple. Like small kids do this, like when we are teaching them the counting, how to count in maths, we give them like a bunch of things, like I have this phone, I have this charger and the AirPods. So if I start counting, I will be like 1, 2 and 3. So now rather than just adding the stuff in the collection, I will be simply counting. And the pseudocode for this is gonna be so easy. I will start directly with the pseudocode. So it is gonna be, we will starting with identity variable, which is gonna be count, and we will start it with 0, and then we will be for item in collection, excuse my spellings, count plus is equals to 1, and then we will return count. Okay, so easy. Okay, so we can take a look at the code example. We will have some kmers in the list. Then we will say okay attc, then we can say gc, oh no, not like this, gc, then we can have tt, then we can have C, oh no, CC or K, and the last one we can have this very long keyword A. Okay, and we will be writing exactly the same as pseudocode. We will start with count variable, which is going to be 0. Then we will be looping over the kmers for kmer in kmers, and then we will say count plus equals to 1, and then we will print count. Alright, so we got 5, 1, 2, 3, 4, 5, we got 5 keywords. Okay, so count was very basic one. So now it's time to talk about the next topic, which is gonna be, let me add a new cell here. Where's the button? Come on. So I can add a new markdown cell here, and this is gonna be collection combine. Okay, so you have already seen an ordinary combine approach in which we combine a single collection into just one thing, and in collection combine what we will have is collection of collections. So what we will end up with is just one collection. So we will be combining several different collections into just one collection. And let's take a look at the pseudocode, and then we will use the bioinformatics function to see the application. Okay, so result is gonna be an empty list collection, and then we will say for item in collection, our result is gonna be, we will call a function, and this function is basically summarizing up a whole collection into one item, and then we will add up into our collection the result collection, so that we have summed up the collection of collections. So we will give it item, and then it's like you know that we are merging with previous results. Okay, let's take a look at the code example, and for this code example we will be using 3 different functions. So we will be extracting the G ID. Let me show you what is the G ID. This is the G ID. So we will be writing a function which will extract this G ID given a description line. So we will give this line to the function, and it will return us this thing. Okay, and then we will define another function which will use our first function, and we will give that function a file, and it will return us all the G IDs. And at the end of the day we will define a function to which we will give a collection of files, like 2-3 files. So, and that function will return that function will call the functions we defined earlier, the 2 functions, and then we will be ending up with the list of G IDs from all of the files. So if we define it for like define it this way, we have like 1,000 files, we can give the names of the files, and then we will get the G IDs of all the sequences available in all the files. So sounds really cool, and it's time to code. So I will add a code block over here, and we will start with our first function to extract the G ID by giving it a description. So we can name it extract G ID. Sounds good. So we will give it description. Okay, I can add a doc string as well here. So we will be like, given a fast description line, return its gene info ID. So the G ID is gen info ID if it has one. Okay, so some files could not have this gen info ID, so we have to do something about those files as well. So we will start with a simple if statement, and we will check if description and the first element of the description, if it's not equals to greater than sign, then we will return none. Okay, and the n is supposed to be capital. Okay, so if like there is a file, this is our base case, and the first line is not starting with greater than sign, then it means that it's not a description file, it's not a description line, it's something else. So we have to simply skip it and return nothing. And then we have to get the fields, and we will simply get the fields by splitting it over something which is very common in the description, and we can see that this is very common, and so everything is separated by this bar thingy. Okay, so we will split it over here, and we will define a function, we will define a variable fields, and then we will just split our description line, and also we want to ignore the greater than sign, so we will start from the first index and then we will simply split. Okay, and we are gonna be splitting over this bar, and now I will be using another if statement, and I will be saying if gi not in fields, which is just gonna be list of several strings, then we will return none. Okay, and let me correct the none, and otherwise I will return fields and 1 plus fields. Okay, so this is gonna be getting a bit confusing for you. So since we have defined the two base cases, I would like to call this function, and we have to copy this description so that we know what we are giving it. Okay, so okay, good. And here I want to do something. Now I want to see that if I use the index function and try to get the index of gi, what I get. So I will simply print, and I will be calling index function here, and then I will give it the gi. Okay, and you can see this yellow squiggly line over here, and you can say that index is not defined. So the thing is that index is a function of the list, so we will have to give it a list in which it will find the index. So our list is this fields list, so we will give it this fields list, and then with the help of the dot notation we can use this function. So I would like to run this and see what we get. So we get 0 over here, and you know that the 0th element is gonna be this thing, but we need this one, so that's why we will add 1 over here. Okay, and if I run this now, I will get 1, and so we can call this thing okay, yeah, we can store this in like gi index, and yeah, so now it's stored in a variable, and now I can return. and I would like to return the element from the fields list. So we will be using our fields list, and I will give it GI index. GI index sounds good, and I will print this. Okay, I need to add one more bracket, just one please, and see, we got this 14430659111, which is exactly the same as this thing. So we are done with defining our first function. And the next function that we are gonna be defining is going to give us all the GID values given a file. So we can call it get GID Ds, a lot of GIDs. So we will give it a file name. Okay, and then we will add a docstring. Okay, and come on, why do you do this? So we will return a list of gen info IDs of all the sequences in a file named as file name. This is getting a bit wordy, but you know that our file name is gonna be the file. Okay, so now here we have to start with the definition of our function, and we will simply open our file with open file name as file, and then we will return. And now it's time to call the function that we created just right now, a few moments ago. We will be using that extract GID, and then we will give it a line, and then our line is gonna be a line in the file. So for line in file, and we cannot give it all the lines, so we have to add an if statement here. We will say if line's first element, like the 0th element, is equals to this. I'm sorry, my phone memory got full, and luckily I was able to see that the video recording stopped. So I guess we were here. So I was telling you that in this if statement, we will be checking if the first element of the line is equals to greater than sign. So if it is not equals to the greater than sign, we will skip all those lines. So then I basically called that functions. Wait, I will add a pass statement here, and then we will run this function. We already run this, and we got these results. We got all the IDs from a file. Okay, so I will comment out this print statement, and now we were defining this get GIDs from all the files. So rather than just giving it one file, this time I will be giving this function a list of files, so we can have like 2-3 files, even 1,000 files, and then it will get us all the gen info IDs. So we have started with this def keyword, then our name of this function, then we will give it files names. Then I was writing the docstring for this function where my video broke down. Okay, so return a list of gen info IDs of all the sequences formed in the files whose names are contained in the collection file names names. Okay, and I will remove this pass statement because it's of no use at this moment. So we will have int list in which we will store all our indexes. We will start with a for loop for file in file names. We can also say it for file name in file names, but yeah, I will do that. For file name in file names, now we have to do something with the file name. And in order to extract all the gen info IDs, we will be using this function get G IDs. So we will say ID ID list plus equals to get get G IDs. Okay, and we will give it file name. Okay, and at the end of the day we will return simply ID list. All right. And that this function returns us a list, as you can see over here. So that's why we can simply add these two lists to append this over here. Okay, and before I call this function, I need to download a file, and I will show you how we can download file from by using blast. So we can go to blast CID nucleotide blast here, and then I can give it a simple sequence atgcd. Like this is for just the testing purpose, that's why I'm giving it a sequence like this, like a random sequence, but I'm sure it's gonna be somewhere in some file, hopefully. So we will blast it, and let's wait. No significant similarity found, so this is not a good reason. So what we can do is we can go to ncbi, and then we can search for a sequence. Maybe we can search a nucleotide. We can search for a gene. Which gene I should search? P53, the notoriously famous gene. So we can go here, and then we can copy some. Okay, clipboard. So we copied, or we can simply just copy this. So we copied that, and rather than putting the sequence, we will put sorry, it was not copied. Hopefully it's copied this time, and then we can blast again. We got some matches. We are not gonna use all of them, so I will be using just the 3 of them. We can click down, or we can go to GenBank, and then I can click all 3 of them. I will be going to send to complete record. I need FASTA format and show G ID. Don't forget to click this checkbox, and I will create file. It's giving me sequence.fasta file, and it's right over here. So we will rename it to s3.fasta. Cool name. So I will copy this, and I will try to paste it in our VS Code directly. It's not working, so I have to do it through the folder. So here, okay, so finally it's time to call our function, and yeah, okay, and I have to give it the file names. I guess I'm getting these lines because this function is not defined at the moment, but it's all right. So our first file is gonna be s3.fasta, and our second file is gonna be sequence.fasta. And now it's time to run the code, and I will make some real estate by hiding the folder directories, and let's run this. Get G IDs unindent does not match outer indentation. Oh yes, so we have to call this function here. And here we got all the G IDs 1, 2, 3, 4, 5, 6, 7, 8, 9. And if we have to check this, I will open this file as well, and you can see that how many sequences are there. 1, 2, 2, 3, 4, 5, 6. Wait, 1, 2, 3, 4, 5, 6 sequences here, and in our S3 1, 2 and 3 sequences here, so it's gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have successfully extracted all the G IDs from all the files that we give. Now you can try it with like several files. Okay, and let's move ahead to our next topic in for loops today's video, which is gonna be search. Okay, so this is gonna be like a bit of a huge thingy. Search, what basically does is that you keep on iterating over a list, over a collection, and then you have this if statement, and in that if statement you check if that thing is according to your requirements, and if that thing is according to your requirement, you can return that item. Now, the idea behind using this approach is that sometimes you have like very huge FASTA files and you don't really want to store all the information and then just do a search function or search for a specific sequence in that huge list. It takes up a lot of memory. So by using this approach, we will keep on looping over the items one by one, and if that item is the item that we want, we will simply return this, otherwise we will move on to the next item. So just imagine that you have like a really huge file and you want to look up for something, and in that file that thing is in the beginning, like, so you look for the first item, it's not yours, it's not according to your requirements, you will move on to the next one, and maybe in the third try you found that. So in this way we have saved up a lot of memory, like reading 1,000 sequences, we just read only 3. So I guess you got the basic idea what I'm talking about. So we will start with the pseudocode now. So the pseudocode is going to be very simple. So for item in collection, and we will be using the test if test item, and we will return. Now you need to take note here that this test could be complicated. Over here I'm just representing it with the test, but it could be a function, it could be a whole lot of difficult things, depends upon your requirements, what you want to do. And before we look at the code example, I would like to tell you that we are gonna be doing a bit of advanced thingy here, and not that much advanced. So just like we defined like three functions previously to achieve smaller tasks and then do the huge task, like which is my usual approach for all the problems in programming. Similarly, we will be defining like four functions this time, and that four functions will be doing their tasks and getting the job done for us. So our first function is gonna be search FASTA file by GID. So what we are gonna do is given a file and an ID, we will see that if that file has that specific G ID. This is gonna be the very top level function, and top level functions are usually very easy and there are no complicated lines of codes in them, and those functions are basically just the entry points, and the entry points function provide like the data in the correct form so that the lower level functions can use them and do the real work. So our four functions, first function is gonna be search FASTA file by GID, okay, and then we will be giving it the ID and the file, okay, and in this function we will be calling another function FASTA search by GID, FASTA by GID, and we will be giving it ID and file, okay, and then in that function we will be extracting extract GID, and we will give it a line, and then we can have another function read FASTA sequence and then we will give it the file. Okay, so before I start writing the code, I would like to tell you what we want to do now. So here is our, we will take this file, okay, I will close this one. So here we have this sequence and this is our GID, okay. So I want to write something that write a function that I give this GID and I give the name of the file, and it will return me the sequence of that specific GID, okay. So if I give it this GID, it should return this sequence, and if I give it this GID, it should return this sequence. Sounds cool? Now you know what we are gonna do, so let's dive into the code. We will be starting with the function, and that is gonna be the top level function search FASTA file by GID. We will give it ID, then we will give it file name, okay. And in the doc string I will tell you that, oh come on, I really hate this. In the doc string I will tell you that what this function is going to return. It is going to return the sequence with the gen info ID from the FASTA file named file name, and important thing to note, we will be reading one entry at a time until it is found. Okay, so we are ready to rumble. So see, I told you that this is top level function, and it basically corrects the things with the given input, and so that's why here we will convert our id to string, because someone can enter the id in like a enter with a number. So if someone enters a number, this conversion will handle that problem. Then we will simply with open a file. With open, we will give it file name, and we will be opening it as file, and then we have to do something, and we will be adding a return statement here, and then we will call our next function. So, and that function is going to be faster search. My camel case is getting pathetic at this point, and I don't know how to handle this. So yeah, by yeah, let's by G ID. Okay, I will give it ID, and then I will give it file. Okay, and you can see this squiggly line over here because we haven't defined this function. So the next function that we are going to define is going to be this one, faster search by GID, and oh no, yes, and we will be giving it ID and file. Okay, or we can say it, okay, file is also good. So faster search by GID, and this function is gonna return something by using another function. So we will, since we are already giving it the file, and we are giving it and we are opening the file over here, we don't have to open the file again. So we can simply start our for loop, and we will say for line in file, and then we can we can start with our if statement. If we will check that line zeroth element is equals to greater than sign, and we will check if the id equals to, and we will call our function, another function, get GID here, and then we will give it the line. This is going to be the function that we defined earlier. So we will check two things: if line is equals to the greater than sign, and if GID is equals to the GID present in that line. So if those two things are correct, and that is our condition, then we will do something. We will return something. We will return the sequence. And how we will get the sequence? By another function, and that is going to be read faster sequence. We will give it the file again. Okay, so now it's time to define our read faster sequence, and we have to give it the file. Okay, maybe I will add the doc string later on. Okay, so read faster sequence. So we will start with our empty string, and then we will start our for loop for line in file, and then we will be checking again if line is starting with the greater than sign this time. That we will return the sync, because now we want the sequence, not the description. If line line zeroth element is equals to greater than sign is yeah, then we will return, because and at that point we know that we are done there, a new sequence is starting and we are done with the sequence. And if it's not starting with the greater than sign, then we will keep on appending our sequence, and we will uh, go from start of the line till the last character, because last character is the new line character and we don't really need that. Okay, now time to define our very last function, which is gonna be this G ID, because there is this squiggly line over here. So we will redefine G ID. I will give it description, and then we will be doing that fields thingy we have done before. I could have used the previous function, and then I will be starting with 1 and going till end, and then I will split it this bar. So now we have to check if fields and GI in fields. If fields will check that if this list is not empty, and then we will also check that if GI is available in the fields, then we will return. And we will be returning the same thing, fields 1 plus fields dot index, and then we will get the index of GI. Okay, sounds really good. Okay, it's time to call our top level function, and we will call it, we will print okay, and then we have to give it some ID. Which ID you want to give? Let's maybe take this one, because this is a small sequence, we would be able to check it if it's okay. And file name is gonna be longest seek.pasta. Okay, let's run this. So we got this sequence GAGCGT, GAGCGT, GAGCGT. Let's give it the ID of this sequence, and this time our sequence should be very long. See, this bar got very small, and we got this. Come on. Okay, we got the correct sequences, so we are done with this. Before we move on, there is a task for you. So these three functions, get GID and read FASTA sequence, and this FASTA search by GID. You can define these three functions by using the while loop as well. Here you know that I have been using the for loop. You can do the same thing by using the while loop. So that is your task, to achieve the same task by using the while loop, and doing so will really help you, because you would be able to understand the code in like really proper way, and your concepts will get really clear. Before I move on, I would like to share a special case for a special case for search iteration. And in this thing, rather than simply returning that thing, we will return true or false. Okay, and I will not be writing the pseudocode for this. I will simply go with the code. and we can define two functions, and you have to be really focused at this point because I'm gonna be asking you a question after doing this. So we will say def, and we will define RNA sequence is valid and DNA sequence contains N. So we will say that RNA so we will give it a seq, and then we will start our for loop for base in seq, and we will check if base not in the string, we will give it use UCAG oh no, I'm basically giving it all the nucleotides in capital and small, and since it's RNA I'm giving it UCAG rather than TCAG. Okay, so I will return false because this is not we are using this not. So if the base is not found in this, then return false, and we will be checking this for every base, and as soon as there is some character in the sequence which is not in this string, we will return false. And if the for loops ends without finding anything, we will return true, because then we have checked all the bases and our function never came across this line, so now we can return true. And then there is another function that I want to define, and that is DNA seq contains N. So we will be checking if our DNA sequence contains N. So we will give this the seq again for base in seq, and we will check if base equals to N, then we will return true. Now you know that it's time for me to ask you a question, and the question is that over here in RNA-seq is valid function, I have also added this false return and this true return, but here in this function I am just returning true and I am not returning false. Does it means that my function will always return true? And what will happen if N is not in that sequence? I will give you some time to think, and I will eat chips. Okay. I guess you got the answer, and the answer is that if this function is not gonna be able to find N, it will return none, and none is already considered as the negative boolean or the false boolean. So if there is no N, it will return none, and that will be false. So we don't need to add that false thingy over here. I can call this function, but yeah, it's very trivial, so you can do this once you go to my GitHub page and look at the code and try to practice over there. So we will move on to the filter, and the filter approach is really cool. So this time we will be filtering the stuff that is that we want. It's just like you when you are searching for something on a website, you have those drop down menus where you can choose different filters, and only those products are shown to you. So the filter approach has different different types, so we will be talking about them one by one. So first of all, we will talk about filter do. So in filter do, if you find something, you will do some stuff with that. So I will start with the pseudocode directly. So we will be starting our for loop for item in collection, and then and before I do anything, I would like to add some comments here. And we could have initializations at this point, because we can keep on updating that initialization and then we can resolve. And in the next line we will just check if test and item, and then we will add some statements using the item. Okay, so this is basic pseudocode. It's very easy. It's time to take a look at the code, and this time we will be defining a very basic function, and we would like to print all the headers in the FASTA file. So we will start by the def keyword, and the name of the function is gonna be print FASTA headers, and then we will give it file name, and then we will open with open as file, and then we will start our for loop for line in file. Then we will check the line. If the line is starting with greater than sign, 0th element is equals to greater than sign, then we will print line, and we will not print that sign, and we will not print that next line character which is at the end of every line. So we will start with the second element, and then we will stop at the second last element. And if I call this function print FASTA headers on this file, longest sequence.fasta, don't do this, please. Okay, we got some error, so it should be line, not line p. Okay, we got another error with open file name as file for line in file. If line 0 is greater than sign, print line, and longest sequence. Oh, we don't have this file, so longest seq.fasta. Okay, so we got this 1 2 3 4 5 6, because we know that there are 6 sequences. Now we will be talking about filtered combine and filtered count, and then we will have our last topic for today's video. And filtered combined and filtered count are very similar to what we have done earlier in let me go up there. We have done this combine here, right? So filtered combine is going to be very similar to this one. The only difference is going to be that rather than simply adding or subtracting or doing whatever we want to do over here, we will check first. So that is our filter by applying the if statement. And then we have the filtered count. So this is our count. So rather than simply adding everything, like counting everything, we will counting only those things which fulfill our requirement. Okay, and that's pretty much it. I will add the pseudocode for you to have a better understanding. We will start with combine. So we will start with result, which is gonna be an identity value. Then we will start our for loop, for item in collection, and then we will check if test item. Then here we can do all those three things. I will simply copy that. We are talking about combine, right? So I will copy these things, and you know that this is very similar to the previous thing, so I will add them here, and I have to correct the indentation. Okay, and then at the end of the day I can return result. All right, so similarly we have filtered count, and filtered count is gonna be very similar to filter to the count we talked about earlier. So count, so it's I will talk about the pseudocode now. So we will have the count variable, which will be 0 at the beginning. For item in collection, we will be doing our test here. So if test item, then we will append our count, and at the end we will return. Sounds good. So now I have another task for you, and that is to think of a scenario in which you can implement filtered count and filtered combine approach in a bioinformatics or just an ordinary function. So it's time to talk about our very last topic of today's video, which is gonna be nested iterations. Okay, and in this topic and this thing, what we will do is we will be doing more than one for loops. We will start a for loop for a in items, then we will be doing like for elements in a, things like that. Like if you have like a collection of collections, so you will be doing like for collection in collections, and then you will be like for item in collection. So we will take a look at pseudocode. I guess you got the idea. Like if you have followed this video and practiced alongside, then it would be very easy for you at this point, and if not, you can always ask in the comments down below. So for outer in outer collection, and then we will call another for inner in our inner collection, and then we can do something with inner and outer. So now we have two things. So we have an outer, we have an inner, and we can do something with both of them. I have a really cool example for using this implementation. So we will be trying to print our codon table. So I will be needing a function, and we can import that from our file. So we will be writing this line from py for binf. I don't know why it shows twice. Import, and we will import translate our codon. Okay, and now we will be defining print codon table, and this function don't needs any arguments because this is just for the explanation purpose. I can add a doc string print the DNA in a nice but simple style or arrangement. Okay, and we will start with our for loop. First for loop, for base 1 in And we also have to define our DNA bases, which is simply gonna be a list of our RNA, and this is gonna be a list in which I will add the RNA, which is gonna be A, U, G, and C. Okay, and for base 1 in RNA bases, then we will be having our base 2 for base 2 in RNA bases, and then we will be for base 3 in RNA bases. Okay, and as we know that this one codon is made up of 3 different base pairs, so we have 3 for loops over here, and then we can simply print, we will print base 1 plus base 2 plus base 3, and then I can do the translation by using our translate RNA codon function, and I will give it base 1, base 2, and base 3. Okay, and then we can do something cool here, and that is gonna be, we can use AND. This AND simply add something after the print statement, and here once we are out this for loop, we can print a new line, and then once we are out this for loop, we can print a new line again. And that's pretty much it. Now we can simply call this function. Okay, see, this is a very bad way. Oh yeah, so I have to give it 1 rather than these 3. So see this, our RNA codon table is printed in a really nice way, and that's pretty much it for this video. I hope you really enjoyed this one and you have learned a lot. And if you have any questions, comments, or concerns about this video, feel free to comment down below. And if you want to read about this whole topic, and you can go to the website bioinformaticsguy.info. You can also join our Bioinformatics Guys community, which is a Facebook group, and you can also check out my social media if you want to know more about me. And thank you very much for watching, and see you around in the next video.